Hello everyone. Today in this video, I'll be talking about the linear layers in neural network. Yeah, so to be honest, this is my first technical video on YouTube, so bear with me. Yes, let's directly jump on to that. So linear layers are basically they're at the end of any neural networks. So the use of linear layers is to convert the input features we get from all the preceding layers and to transform that input feature into the output features of uh, our desirable shape, you can say. So why we do that? Because at the end we have to flatten our tensor in a single dimensional array, because we have to relate it with our um, classes that we have in the classification. So today I'm going to show you how it happens, how its implementation basically in normal using normal Python matmul operation, and as well as in how it happens in the PyTorch linear function. So yeah, let me just quickly change my PyTorch environment, and I'll be showing you the implementation in default Python IDE. Okay, so let's first, we'll do that later. Okay, so if we have a tensor with maybe it's a four size of size 4. So to import this torch first, so quickly do that. Yeah, so let's say if we have some features like this. Say 1, 2, 3, 4, and load. Then, so in this case, I forgot to mention it. How it exactly transforms it into output features is, if we have in features like this, the linear function adds a word matrix and does the matrix multiplication and gives us the output, which is completely a single dimensional output. So we need to have a wet matrix here as well. Maybe it's and it's not a flattened array. Wet matrix is a tensor. Basically, it's a multi-dimensional tensor. So we have something like, maybe I'll use 2, 3, 4, 5, 6, 7, okay, let's just quickly check the shapes of both the tensors. Size 4, and then size 3 by 4. Okay, so now if we just do matrix multiplication, it would be something like, oh I forgot to mention the data type for this. Oh, sorry. Yeah, okay, here we go. And if we do that again, okay, so here we get something output, something like this, as tensor. Maybe I can share it. So it's a size 3. And so basically we have output features of we want the output features of um, of shape 3. So now I'll show you how it happens in the PyTorch, using the PyTorch linear function. So for that, maybe I would say if we have so it's a fully connected layer, so we just have to call the linear function. Sorry, it's not a function, it's class basically. And let's say, yeah, in features. So we have to provide in features. Sorry, features, but we features equal to 4, as we are going to use 1, 2, 3, 4 tensor. So that's why the input feature has has a 4 shape, so shape of 4 for 4 by 1, you can say. And then output feature, let's say we want a tensor of shape 3. So yeah, and after this, maybe just we can call it directly, because linear nn.linear is basically a Python class. So and it has a render method or magic method, you can say. So we can use directly fc as a callable object. And yeah, let's see how it goes. fc, and we have to provide in features. So as you can see, we got this tensor of shape 3 and some value, something like this. We got different outputs because the weight matrix which linear function uses, it's the values of that are completely random. So yeah,